So this is just the second part of section 5.7, and I hopefully can finish this part in a half hour, so I don't need to make a part 3. So I'm just going to jump into the factoring and maybe do some more number computing in my head. So in problem 14, it has 3 terms. There isn't a common factor. If there wasn't a number in front of the square term, I would cite factor. But because there is a number in front of the square term, I need to rewrite with 4 terms and then factor by grouping. So what do I do to get started? If I'm going to take a problem that has 3 terms and I'm going to rewrite it with 4 terms, I need to know my target number. So I multiply the coefficient of the square term times the constant. That gives me the 60. Now I'm going to need double negative numbers that multiply to 60 and add to negative 23. That's using my template to get the signs. That's the second row of my template. And I'm going to speed up the process here by just writing down the numbers rather than writing every possible choice. The double negative factors of 60 that do both multiply to positive 60 and add to negative 23 are negative 20 and negative 3. If you multiply negative 20 and negative 3, they multiply to positive 60. If you add negative 20 and negative 3, those add to negative 23. And this will allow me to take the negative 23x and rewrite it as negative 20x minus 3x. I could have written minus 3x minus 20x. That wouldn't make any difference in terms of my final answer, but my work would look remarkably different. If you are trying to match what I'm doing, if you switch the order, not a big deal for your final answer, but a huge deal for trying to follow what I'm doing, because the work looks remarkably different. So I took my original problem, I split it up into the 4 terms using the strategy, or using the 20x and the 3x. Now I'm going to split the problem into halves and do double common factor factoring. So I'm going to pull out my common factor between the 5x squared and the minus 20x, and I'll pull out my common factor between my minus 3x and my positive 12. Between the 5x squared and the 20x, 5 is the biggest number that divides into 5 and 20. And both terms in the 5x squared and the 20x have an x, so I need an x in my common factor to the left of my vertical bar. Take the smaller exponent and just get an x for my common factor. And I'm just going to write in the x minus 4 that's left over without talking you through it. Hopefully you could do that. To the right of my bar, it's more complicated. The first term is negative, so I need to factor out a negative. Both terms don't have an x, so I don't get an x for my common factor, but 3 goes evenly into 3 and 12, and it's the biggest number that goes evenly into 3 and 12. I'm going to put a minus 3 in front of the parentheses I create for factoring out the common factor of minus 3x plus 12. To fill in that parentheses, because I factored out a negative, I need to switch signs. So this minus sign is going to switch to the implied plus sign. This plus sign is going to switch to a minus sign. I factored out a 3, so I need to divide numbers by 3. Have my signs filled in already. This 3 is going to turn into a 1 because 3 divided by 3 gives me a 1. I leave the x. This 12 is going to turn into a 4 because 12 divided by 3 is 4. When you're rewriting with 4 terms and factoring by grouping, you 100% need to get identical parentheses when you get through the step of doing the 2 different common factors. If you don't, then you haven't broken up the problem into 4 terms properly, or you did some factoring wrong. Both of those would be acceptable answers. 16 has three terms. There's not a number, in front of the square term, but there's a negative in front of the square term. There isn't a common factor for number 16, but if I tried to jump into my factoring, I'd probably mess up because my template implies, or it only works if the number in front of the square term is positive. So in both problems 15 and 16, there isn't a common factor, but the first term is negative. I best factor out a negative, or equivalently a -1, before I go into my 2 parentheses factoring. And anytime the first term is negative, I have to factor out a negative. And anytime I factor out a negative, I switch signs. So this positive sign was going to flip to negative. This negative sign was going to flip to positive. And that's just what I did. I changed the signs to accommodate factoring out that -1. And now I'll move to my template. This is the second row of my template. I need to find double negative numbers that multiply to 12 that add to -7. So I'm looking for double negative numbers. They have to multiply to 12, and they have to add to -7. And for this problem, because after I factored out the -1, there's not a number in front of the square term, I don't need to rewrite it as 4 terms. I don't need to factor by grouping. Once I figure out the numbers that fit the criteria, multiplying to 12, adding to -7, I can get this thing factored with just by writing down the answer without doing any special work. The numbers I'm going to need are -3 and -4. Because if you multiply -3 and -4, you get +12. And if you add -3 and -4, you get -7. So the -3 and -4 are going to be the lasts in my parentheses. To lead off my parentheses, I split the b squared evenly into the first position, meaning I divide its exponent by 2 and get b to the first, and lead off my parentheses with a couple of b's, and these numbers are going to end my parentheses. And the order that you choose to put the -3 and the -4 in terms of which parentheses the -3 goes in or which parentheses the -4 goes in, it's just a matter of preference, but you need one parentheses with a -3 and the other parentheses with a -4. But both answers that I have written are correct, and there's alternate variations. So in front of your parentheses, you either have a -1 or just a negative sign, and you need one parentheses with a b-3, a second with a b-4, matters not the order. 17 and 18, there isn't a common factor, and the first term is positive, so there's no need to rewrite by doing any first step greatest common factor factoring or factoring out a -1. In 17 and 18, there's 3 terms, and there's not a number in front of the square term, or there's just an implied 1 in front of the square term. This is another site factoring problem. Both 17 and 18, I'm not going to rewrite with 4 terms. I'm just going to go into my site factoring, and it's the same level of my template. I'm going to need double negative numbers that multiply to 24 and add to -10 when I go to fill in my parentheses. I know that the y squared is going to split evenly in the 2 parentheses in the first position. I divide the exponent by 2 and get I get y to the first to lead off my parentheses. And the numbers I'm going to need are -4 and -6, because if you multiply -4 and -6, those multiply to 24 like they need to. And if you add -4 and -6, those add to -10 like they need to. Those are the only 2 integers that will multiply to +24 and add to negative 10. And those numbers, minus 4 and minus 10, will go in my minus 4 and minus 6 will go in my parentheses in whatever order I choose. So I wrote both versions of the answers. Problem 19 and 20 have 4 terms, so I'm going to factor by grouping, which means I need to split the problem into groups. Put my vertical bar in, make a left group, and a right group. In the right group, I don't have to worry about factoring out the negative that I would if that sign was a plus. In the left group, I'm going to plot a common factor of 5x. 5 is the biggest number that goes evenly into 5 and 30. Both terms have an x. The smaller exponent is an x to the first power. When I factor out a 5x, I'd be left with an x plus 6. I'm going to bring down the plus sign. And from that 3x plus 18, I'm going to factor out a 3 and be left with another x plus 6. So I'm doing common factor factoring in my head. Most students can. If you can't, that's fine. It's just going to take you some more time. You'll really want to perfect section 5.1. You might want to go back and review it if you're not comfortable with the common factor factoring. The important thing for this problem was it had 4 terms, and when a problem has 4 terms, I automatically think I need to factor this by grouping. And when I factor by grouping, I split the first 2 terms and the second 2 terms, and I do 2 common factor factorings. Problems 21 and 22 have 3 terms. If there was a number in front of the squared term other than the implied 1, I rewrite it as 4 terms and factor by grouping. But in problems 21 and 22, there's not a number written in front of the square term, so I should be able to sight factor. Both of these we're going to use the top row of my template, and the numbers I'm going to need for my sight factoring in problem 22, they need to be both plus, because that's the top row of my template. They need to multiply to 7, and they need to add to 4. I'm always looking for numbers that multiply to the last number, add to the middle number. And the problem I'm going to run into here is the only numbers that are double plus that multiply to 7 are 1 and 7. If I add the numbers, they don't add to 4. So the only possible choices that I have are 1 and 7, because those are the only numbers that are double plus that multiply to 7. Because that only choice that I have doesn't add to 4, that means there's no combination of numbers that will do both criteria. That makes this a prime polynomial. Just gauging my time, I think I have 11 problems to do, might be 12. I better do them in 2 minutes each to make the video appropriate length. Don't really want to do a part 3, so let's see if I could do that without making it feel rushed. In problems 23 and 24, there's a common factor. In 23, both the coefficients are 3, both the terms have a y. I need to do greatest common factoring first. If I don't do greatest common factor factoring when there is greatest common factor factoring, then the technique that I ultimately need to factor might be hidden from me. So in problem 24, I'm going to factor out a 3 because that's the biggest number that divides into the coefficients. Both terms have a y. The smaller of the exponents goes for my common factor. So my common factor is going to be 3y. To fill in my parentheses, I'm going to divide by 3 and take a y away. The first term is going to be a y cubed when I divide the 3 by 3 and take one of the 4 y's away. I'm not changing signs because I didn't factor out a negative, so that minus sign is going to stay between the terms inside the parentheses. And to the right of the minus sign, when I factored out a 3, I need to divide that 3 by 3 That will leave me with a 1, and I took that y away. What's left inside my parentheses, to me, is clearly a cube problem. It's a cube problem because the y cubed can be written as y times y times y. I just divide the exponent by 3. And the 1 can be written as 1 times 1 times 1 because I could just cube root the 1. This is a cube problem, so I need to fill in my signs in my template. First parentheses, I keep the sign. Second parentheses, whichever sign I put in the first parentheses, I change. And then the second sign in the second parentheses is always plus. To fill up my parentheses, first parentheses gets 1 from each group, 1 from the group of y's, 1 from a group of 1's. Second parentheses, I form pairs, and I multiply. So my first pair is y times y. My second pair is y times 1. My third pair is 1 times 1. Usually I would just write the answer down and not write that second parentheses with the multiplication left to be done. Ultimately, this is the best answer for 24. Problems 25 and 26 also have common factors that if I don't factor them out, I can't tell the kind of problem that ultimately this is in terms of breaking it into 2 parentheses. In problem 26, my common factor is a 3 because 3 is the biggest number that divides evenly into 3 and 12. I don't get a b for my common factor because the 12 didn't have a b. When I look at the parentheses now, it looks to me like a square problem because the exponent is even and the number is a perfect square. It's a square problem with a minus, so it's got a factor. Square problems with pluses are prime, square problems with minuses factor. To factor a square problem with a minus, any variable, you divide its exponent by 2, and any coefficient or constant, you square root that number. So for the b squared, I'm going to divide its exponent by 2 and get a b to the first power. Because the b came before the signs in the original problem, it's going to go before the signs in my answer. I'll square root the 4 and get a 2. Because the 4 came after the sign in the original problem, the 2 that the 4 square roots into goes after the signs in my answer. So that feels like a good answer for 26. For 27 and 28, they're real similar to problems 25 and 26 in that there's a common factor that just has a number that doesn't have a variable. In problem 28, I look at the 2b squared plus 8, and I know that there's a common factor, and I know that the first step of any factoring problem is to remove a common factor if there is one. So I glanced at 28, figured out there's a common factor of a 2. I factor out the common factor of a 2, and I'm left with a b squared plus 4. And now what's in the parentheses has 2 terms, which means it's either a square problem or a cube problem. Because the exponent isn't a multiple of 3, it's not a cube problem, so this has to be, I guess, a square problem. And it's a square problem with a plus. It's a square problem because the exponent is 2, which is an even number, and the number, the constant, is a perfect square. The square root of 4 is 2, or 2 squared is 4. Square problems with pluses are prime. I can't, in problem 28, break b squared plus 4 into 2 parentheses because it's a square problem with a plus, or it's a sum of squares, which is prime. But it would be wrong to say my whole answer is prime because I was able to one-step greatest common factor factoring. I just can't go further in problem 28, but my answer shouldn't be prime. My answer is only prime if there's no rewriting that can be done to the problem that was given. Since I was able to rewrite it by one-step factoring, it's not prime. I just couldn't go further because what's left is a sum of squares, which is prime. The next 4 problems on the sheet are all 4 terms, And when I see 4 terms, I automatically go into factoring by grouping. When I do 20, or when I do 30, or 32, I'm going to break the problem into halves. In 30, the left half is going to be 2x squared minus 3x. The right half is going to be minus 8x plus 12, and I need to really focus on that minus in the second half and factor out a negative. So, first half in 30, there's a common factor of x between 2x squared minus 3x. When I factor out an x from 2x squared minus 3x, I'm left with a 2x minus 3. The second half, I need to factor out a negative because that second half leads with a negative sign. I'm not going to factor out an x because the 12 in the second half doesn't have an x. But between the 8 and the 12, 4 goes into each, and it's the biggest number that goes into each. So I'm going to put a minus 4 in front of my parentheses from the second half. I'm going to switch the signs and divide by 4 and be left with another 2x minus 3. When you're factoring by grouping, you have to get identical parentheses. If you don't get identical parentheses, then you've made a mistake somewheres. Both of those would be acceptable answers for 30. For 32, I put my vertical bar in, and I need to factor out a common factor between the binomial x squared plus x. I need to factor out a common factor from 12x plus 12. I'm not factoring out a negative with this 12x plus 12 because that sign preceding the 12x is positive. I'm just going to keep that sign. Whereas in the version above it, I needed to factor out a negative and keep that negative, in front of the second parentheses. So between the x squared and x, I'm going to factor out an x and be left with an x plus 1. Since I'm not factoring out a negative, I'm just going to bring down that plus sign. And between the 12x and the 12, I'm going to factor out a 12 for my common factor and be left with another x plus 1. Then I'd write the common parentheses as one of my factors and the x plus 12 as my other. And absolutely no difference in terms of being more or less correct if you have your parentheses flip-flop from mine. (34), it's 3 terms. There's a number in front of the squared term, so I need to rewrite with 4 terms and then factor by grouping. So to do that, I multiply the coefficient of the squared term times the constant at the end of the problem. I need to find the numbers that are plus and plus, because this is the top row of my template, that multiply to that number that I just figured out, that add up to the number that I haven't actually used yet. And those numbers are going to be 3 and 6, because positive 3 times positive 6, they're double positive and they multiply to 18. Positive 3 and positive 6 are double positive and they add to that 9. So the 9x in my problem, I'm going to rewrite as 3x plus 6x in my efforts to rewrite this with 4 terms and factor by grouping. I'm going to separate the problem into halves. Once I get it into 4 terms, I make a left half and a right half. On that right half, if that sign was negative there, I'd have to factor out a negative in my common factor factoring. But since that right half has a positive after my bar, I don't have to worry about factoring out a negative. Between the 2x squared and 3x, when I one parentheses factor there, I'm just going to factor out an x and be left with a 2x plus 3. I'm going to bring down this plus sign, and between 6x plus 9 I'm going to factor out a 3 and be left with another 2x plus 3. So hopefully the common factor factoring is something you can do in your head, and the fact that I'm not really talking through the common factor factoring isn't crippling you. This would be a good answer for 34, but you could have the parentheses switched as well. In problems 35 and 36, there aren't common factors, but in problems 35 and 36, the first term is negative. If I have 3 terms and the first term is negative, I can't just jump into my template. My template needs the first term to be positive. So I need to factor out that -1 if I'm doing problems 35 or 36. And when I factor out a -1, I have to flip my signs. This now will be sight factoring because there's not a number in front of the square term. And to figure out the numbers, I need to use my template. This is the 3rd level of my template. I'm looking for plus minus numbers. So when I go to factor this by sight factoring, because there's not a number in front of the square term, I'm looking for numbers that are plus and minus. The big number gets the plus sign, the small number gets the minus sign. They have to multiply to -6, and they're going to add to +5, and those are going to be 6 and -1. 6 and -1 fits big number plus, small number minus. If I multiply those, I get -6, and if I add 6 and -1, I get 5. So when I go to sight factor this, I'm going to split it and make 2 parentheses. I'm going to leave the -1 out front. I could suppress the 1 and just write a negative sign if I care to. The x squared, I'm going to divide its exponent by 2 and get an x to the first and make that the lead in both my parentheses. And then these +6's and -1's are going to end my parentheses. And it doesn't matter if you write the 1 or you suppress the 1. And it doesn't matter if the x plus 6 parentheses is your first parentheses or it's your second parentheses. All those would be good. 37 and 38, same sort of issue. The first term is negative, so at a minimum I need to factor out a -1. But in addition, in 37 and 38, there's a common factor that I need to pull out in addition to the negative. First step in problem 38, I'm going to factor out a negative because the first term is negative. I'm going to factor out a 6 because 6 is the largest number that goes into 6, 30, and 24. I'm not going to factor out a y because the 24 doesn't have a y. So I'm doing my 1 parentheses GCF factoring with a negative because the first term is negative. To fill in my parentheses, I switch the signs because I factor out a negative and I divide by 6. I'm going to be left with a positive y squared, flipping that sign from negative to positive, a 1 dividing that 6 by 6, and then a plus 5y, plus sign because that negative sign flipped to positive, 5 because that 30 divided by 6 is 5, and then plus 4, positive sign because that negative sign flipped to positive when I divided out a negative, 4 because that 24 I divided by 6 and get 4. Now I'm going to sight factor because inside the parentheses there's not a number in front of the y squared. So I'm going to split the y's evenly in the front of my parentheses, and then I'm going to figure out how to end up my parentheses by going to my template and figuring out what the numbers need to do. This is the top row of my template, so the signs need to be plus and plus. The numbers always have to multiply to the last number, add to the middle number, and the numbers that do that so nicely are 1 and 4, because 1 times 4 is 4, and 1 plus 4 is 5. So one of my parentheses needs a plus 1, the other needs a plus 4, and it doesn't matter which parentheses gets the plus 1 and which parentheses gets the plus 4. When I'm sight factoring, the numbers can go in either parentheses. Try to do a few more. The next 4 problems have 3 terms. They don't lead with a negative. There isn't a common factor. All 4 of these problems are just straight sight factoring. I'm not going to rewrite them as 4 terms because there's not a number in front of the square term. If I have 3 terms and there's a number in front of the square term, I'll rewrite it with 4 terms. But for this one, in problem 40, I can go straight into sight factoring. Split the x squared evenly into the first position in each parentheses. This is the 3rd row of my template. I need plus minus numbers. The big number gets the plus sign. They need to multiply to negative 11. And they need to add to positive 10. And the numbers that will do that just fine are going to be 11 and negative 1. If you multiply 11 and negative 1, that fits plus and minus, big number plus, small number minus. If you multiply those, you get minus 11. And if you add 11 and negative 1, you get positive 10. So to finish up my sight factoring, one parenthesis gets a positive 11, the other gets the minus 1, and anytime I write 2 parentheses, the order that I write the parentheses in is just a matter of how I just happen to write them. 42 is also a sight factoring because it's 3 terms. There's not a number in front of the square term. There's no common factor to factor out. I'm going to go straight into my sight factoring. If there was a number in front of the square term, then I'd rewrite it and use grouping. But since there's not a number in front of the square term, I'm going to sight factoring. I split the y's evenly between the parentheses. This is the bottom row of my template. The bottom row of my template says the numbers I need are plus and minus. The smaller number needs to be plus. The numbers need to multiply to negative 24, and they need to add to negative 23. And that's going to be 1 and negative 24 that do that. Very specifically, 1 times negative 24 is negative 24. 1 plus negative 24 is negative 23. So in my parentheses, one of them gets a plus 1, the other gets a minus 24. Let me just do the last problem, even though the video is longer than I want it to be, just so you have everything, all the evens in your notes. It's just another sight factoring. It's kind of a common factoring, so I just threw a bunch of these at the end. In problem 44, I have 3 terms. I don't see the first term leading with a negative, so I don't need to factor out a negative. And there's not a common factor. So it's, again, this is another sight factoring again. And this is the bottom row of my template again. So I need plus minus numbers. The small number gets the plus. The numbers need to multiply to negative 3 and add to negative 2. And that's going to be 1 and negative 3. Because if you multiply 1 and negative 3, you get negative 3. If you add 1 and negative 3, you get negative 2. So one of my parentheses will get a plus 1, and the other will get a minus 3. And always, 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 the order that you write your parentheses in doesn't make the least bit of difference. So we're at 34 minutes. I better stop this thing, and we'll just call this done.